Day 6.8, our first example here. Find the length of side AB to the nearest tenth of a centimeter, or 1 decimal place. So our reference angle is 37 degrees, making this side the opposite, this the hypotenuse, and this the adjacent. So we are asked to find the opposite, and we are given the hypotenuse. So the trig ratio, which deals with opposites and the hypotenuse, is the sine. So we can say that the sine of 37 degrees equals x over 11, or opposite over hypotenuse. X equals 11 times sine 37, and our calculator will tell us that x equals 6.6 centimeters when rounded. Jamie's kite string is 35 meters long. It makes an angle of 50 degrees. Let x be the horizontal distance in meters to the kite. What is the horizontal distance between the kite and Jamie? Well, 50 degrees is our reference angle. So we can make our labels. We're given the hypotenuse, which is 35 meters, and we're asked to figure out the adjacent, which is x. So adjacent over hypotenuse is cosine. So we can write that the cosine of 50 equals x over 35. Becomes an algebra problem where x equals 35 times cosine 50. Now we punch these numbers into our calculator and get a value of 22.5. Jay is supervising the installation of an escalator at a new mall. The escalator will make an angle of 30 degrees with the floor and will rise a vertical distance of 6 meters. What is the horizontal distance of the elevator to the nearest tenth? Well, our reference angle is 30 degrees, so we can use this to label our various sides. We are looking for x, which is the adjacent, and we're given the opposite, which is 6. So adjacent and opposite deals with tangents. So we can state that the tangent of our reference angle, the tangent of 30, equals 6 over x. Using algebra, we come up with a statement that says tan 30x equals 6. If tan 30x equals 6, then x by itself equals 6 divided by tan 30. Punch these values into our calculator, giving us a value of 10.4 meters for x. In this question, we're asked to figure out the degrees. A storm caused by a 13.5 meter hydropole to lean over. Let's see, let me restate that. A storm caused a 13.5 meter hydropole to lean over. The top of the pole is now 11.8 meters above the ground. Find the measure of the angle between the pole and the ground to the nearest degree. So our reference angle, P, is what we're trying to figure out. We're told that the pole leaning over is 13.5 meters. That's our hypotenuse. And the height is 11.8 meters. So relative to the reference angle, 13.5 is our hypotenuse, and 11.8 is our opposite. So the tangent ratio, the ratio that uses opposites and hypotenuse is the sine. So we can say the sine of angle P equals 11.8 over 13.5. If the sine of angle P equals this fraction, then the angle P by itself equals the inverse sine of the fraction. So once we have this stated, we can simply put these numbers into our calculator. We press second mode sine to give us the inverse sine, put in the fraction, and come up with a value of 61 degrees. Example 5, the inverse tangent ratio. A tower is supported by a wire. The wire is attached to the tower at a height of 19 meters and to the ground 8.1 meters from the base of the tower. Calculate the measure of the angle formed by the wire and the ground to the nearest degree. So we're trying to figure out what this angle is right here. So we're looking for W, our reference angle. We're given 19 and 8.1. 19 is our opposite, and our adjacent is 8.1. So the tangent ratio that deals with opposites and adjacents is the tangent. So we can state that the tangent of angle W is 19 over 8.1. Now if the tangent of W equals this fraction, then W by itself equals the inverse tangent of 19 over 8.1. We plug those values into our calculator, and it gives us an angle of W of 67 degrees. Example 6, the inverse cosine ratio. Elena is building a wheelchair ramp to a deck that is 90 centimeters high and 500 centimeters long. Calculate the measure of the angle formed by the ramp and the wall to the nearest degree. So here's the ramp, here's the wall. This becomes our reference angle, which we'll label theta. Now, relative to the reference angle, we have an adjacent of 90 centimeters and a hypotenuse of 500 centimeters. The trig ratio that deals with adjacents and hypotenuse is the cosine. So we can state that the cosine of theta is 90 over 500, adjacent over hypotenuse. If the cosine of theta equals 90 over 500, then theta by itself will equal the inverse cosine of 90 over 500. Put these values into our calculator, and it'll give us an angle of 80 degrees. So this reference angle right here is 80 degrees.